Okay, for this video, our goal is to find the intervals for which this function is increasing or decreasing, and this always begins with our study of the derivative. So let's first find our derivative for this function. F prime of x is going to be the derivative of the numerator, which is 2x times our denominator, and it's going to be then minus our numerator times the derivative of our denominator, which is 2x, and it's all divided by our denominator squared. All right, we can now simplify this derivative down. We have a 2x cubed minus an 18x and minus another 2x cubed divided by x squared minus 9 squared. And our 2x cubes cancel out, and our derivative simplifies down to f prime of x is equal to negative 18 times x over x squared minus 9 squared. And from here, we can see that both positive and negative 3 make our denominator 0, which makes our derivative undefined. But keep in mind that it's not a critical number for us because plus and minus 3 is not in our domain of our original function. So off to the side, very important to note that x equals plus and minus 3 are not critical numbers, since they are not in the domain of our original function f of x. So now we need to look to see where our derivative is possibly equal to 0, and f prime of x is equal to 0 when our fraction is equal to 0. And that can only happen when our numerator is equal to 0. So that gives us negative 18x equal to 0, which implies that x equals 0 is that number. And we notice that this number is critical because 0 is in the domain of the original function. So this is definitely going to be a critical number. All right, next up for us is to draw a number line where we plot the sign of the derivative. So we're going to place 0 on that number line and then study the value of their derivative for values that are larger and less than 0. So if we take a number greater than 0, such as 1, and substitute it into our derivative, we'll notice that f prime of 1 is going to be equal to negative 18 times 1 divided by 1 squared minus 9 squared, which is going to be less than 0. So for 1, we have a negative derivative. Now let's look at f prime of something smaller, such as negative 1. F prime of negative 1 is going to be negative 18 times negative 1 over negative 1 squared minus 9 squared. And that's going to be greater than 0 because we have a positive numerator and denominator. So any value left of 0 on a number line will give us a positive derivative. And now we know that from negative infinity to 0, we have an increasing function. And from 0 to infinity, we've got a decreasing function. And we can now answer the question. So f of x is increasing on the interval from negative infinity to 0, and f of x is decreasing on the interval from 0 to positive infinity. And again, we did this by finding the critical numbers, plotting them on a number line, and then testing out the sign on different sides of those critical numbers. And it always starts off with a correctly found derivative.